Hello, this is a video on lesson 5-6, the first part only solving exponential equations, and part B will be solving logarithmic equations. We're going to start out using Desmos because you can use this trick on any equation that you don't know how to solve. Now, just a quick and friendly reminder, just make sure that you're not being dependent on Desmos. This is just a good trick to use whenever it is available to you. So let's start out with number 1. It says solve by graphing. Sketch the graph and label the solution. So what you can do is you can split it into a left side versus the right side. And just because you're using the tested version of Desmos, go ahead and set each side equal to y. That way it is much easier for you to see the intersection point. So that's what we're looking for. We're looking for the x value of the intersection point, and that should solve our equation for us. So let's pause that video, let's graph it on Desmos, and let's see what we get. Okay, so as you can see, I've graphed the left-hand side of the equation here and the right-hand side here. And all you have to do is click on the intersection point here, and it gives you the x value when y is 2. So our solution is going to be 0.693. And anytime that you find the intersection point, remember Desmos is going to round it to the nearest third decimal. Let's go ahead and look at this one. I'm going to do this one with you. So it's 2 to the power of x and 3 to the power of negative x. All right, I'm going to pause it and graph it, and let's look at it. All right, so here's our results. This first one right here, the 2 to the power of x, notice how that base is positive, so that's going to give you that red line, which is a growth. And then 3 to the power of negative x, so if you have a negative exponent, what that's going to do is it's going to move the 3 to the denominator and cause that to be a decay. So this is exactly what I expected. Let's go ahead and click on our intersection point right here. And it looks like our solution is going to be x is equal to 0. Oh, I didn't sketch it on the last one. We're going to go ahead and we're going to sketch that growth and that decay. And this is what our solution looks like, but it's of course only the x value of that. Okay, I want you at this point, go ahead and stop the video. I want you to graph this and solve it and see if you get it right without any help. All right, so here's what I got after graphing the left and the right side. I wind up with x is equal to 1/2 or 0.5. So if I'm going to do a little sketch real quick. Oh, I forgot what my y value was. That was 2. Okay, and final answer 1/2 or 0.5. Okay, so in the second part, we're going to learn how to do this without technology. We're going to use something called base equals base. They don't call it that in the textbook. That's kind of a thing that I do. What they do is they use something called the property of equality for exponential equations. Okay, so basically what you do is you realize that you have the same base on either side. So let's say I've got base 10 here, base 10 here. If the bases are equal to each other, they're both isolated on the left and right hand side, what you can do is you can just simply drop the bases, and then you can make the exponents equal to each other. So it's actually pretty simple, but it's very specific. That's why we have 3 different techniques we're going to learn in this lesson. This is the second technique. So if it doesn't fit, it's just not going to work. So let me give you an example of what this looks like. So over here, I notice that I have base 3, and then on the right hand, I also have base 3. So that means that this exponent is going to be equal to this one, and it just makes a statement. So sometimes it's really simple. You just say x equals 5, and then sometimes, like for example, this one right here, you have base 10 on either side. If you look at the exponents, 3x is equal to x minus 9. Then what you're going to have to do, realize that it's a linear equation, and you're going to have to get x by itself and solve it that way. So sometimes they're very easy, and sometimes you have a lot of more work to do. There is something that you do need to understand. It's not always going to show up with exactly the same base. So you may have 10 on one side, and you may have 100 on another, and you have to rewrite 100 as 10 squared. Or if you see a 64, 64 can be written as 8 squared, or 4 to the third power, or even 2 to the power of 4. There's a lot of numbers that can be rewritten. So let's practice that skill for a couple of examples here. So this one says write 125 using base 5. So this is one of our popular cubes. So instead of writing 125, I can rewrite that as 5 to the power of 3. That's useful if one of the sides has a base 5 and then the other one's 125. You have to get the bases to match to use the rule. Okay, over here, most of the time when you see a fraction, like if you've got a 2 to the positive 1 power, this means that you're probably going to need to use a negative exponent. So that 2, all you simply have to do is move it to the denominator and just change the sign of that positive 1 to negative 1, and that's how you do it. So just be aware if you see a fraction, you're probably going to need to use a negative exponent. So let's see this in the process of solving. So this one is already solved for you, and what we're going to do is we're going to justify each step. So I can't really quite highlight anything just yet because I've got an 8 equal to 2. They are not the same. So what happened is that we took this 8 and we rewrote it as 2 to the power of 3. So we're going to write that down. Why did we do that? Okay, we did that because we want to have the same base on either side. Now, do you see how the bases are the same? We're almost done though. So when I wrote the 2 to the power of 3, you see how I've got a 3 and then I already had an existing exponent here? What you have to do is you have to distribute the 3 into the 2x and the minus 1. So we're going to distribute. Got to spell it right. And that gives us 6x minus 3. Now that you have an exact base, you can go ahead and drop the bases and you can set the exponents equal to each other. And that is called the property of equality for exponential equations. It's a lot. So property of equality for exponential equations. That's a lot. Okay, so next up, you just have to realize that you're going to get x by itself. So it looks like we went from 6 to 2. So they subtracted 4x from both sides. So that left us 2x minus 3. So we showed our work here. So that's perfectly fine. And then what we're going to do is we're going to add 3 to both sides. Yes, that matches because negative 4 plus 3 is negative 1. And then we divide both sides by 2. And then our final answer is going to be negative 1/2. I don't have to check my answer because exponential equations, the domain is all real numbers. There's no restrictions. So that means I'm not going to have any kind of extraneous solutions. So I am ready for the next one. Okay, so what we're wanting to do here is we want to make sure that we have matching bases, and we do not. I can tell right now that I'm going to need to write each side with a base 10. So 100, that is simply going to change into 10 squared. And notice how I'm using parentheses to change 100 into 10 squared. Same thing here, this 1 over 10, if it's a fraction, it's likely that we're going to have to move it up, and we're going to use a negative 1 to fix that. So it's positive here in the denominator, and when I move it up to the top, it's going to be negative 1, but I still have this x minus 3 here. Now we're going to do the same thing. We are going to multiply across these exponents. So this is now going to wind up being 2x. And this one I have to multiply, I have to distribute the negative 1. So it'll be negative 1x plus 3. Make sure you distribute. And then now I can go ahead and highlight both of these signs because of that property of equality of exponential equations. I am allowed to drop that base, and I can write down the exponents. Now, as long as you're comfortable with linear equations, this is going to be no problem. It doesn't matter to me how you get the final answer as long as you do it correctly. There are multiple ways to solve linear equations. This is just the way that I chose to do it. So final answer is going to be x equals 1. You can always go ahead and take that 1 and plug it back in there. The reason why learning this method is important is because you're not going to have Desmos available to you at all times. And even on your test, you're going to have Desmos on part 2, but you will not have Desmos available in part 1. So you're going to have to learn this skill for sure. All right, let's look at this last one over here. Okay, I think, I suspect that we're going to be needing to write everything with a base 5. Okay, so I set this one up. I didn't change anything, but if that's 5 to the power of positive 1 in the denominator, if I move it up, it will be 5 to the power of negative 1. 25, that's going to change into 5 squared. Now I'm not going to do anything else other than change the base. So 25 is 5 squared. 1 over 5 is 5 to the power of negative 1. Okay, now I'm going to look at any existing exponents. I'm going to go ahead and distribute here. So it's going to be negative 1 plus 1x, changes its sign. And then I'm going to distribute here. So it'll be 4x plus 2. Now that I have all of that taken care of and simplified, I can use my property equality and drop base 5. And then I'm going to just write down the exponents. And then once again, I've got a linear equation. I'm going to go ahead and subtract 4x. There's lots of different ways you can do this correctly. I'm going to add 1 this time. And then my last step is to divide by negative 3. And that's my final answer. And that's it for page 1. All right, let's flip it over on the back. I've got a couple of equations for you to solve on your own. I will give you a hint on this one. Looks like you're going to need to write it as base 9. It's possible for you to use base 3, but it's easier to use base 9. And on the second one, you don't have to change that base. It's already ready for you to drop the base. So stop video, try both of them out, and see how you do. Okay, so I've already written this as base 9. I do need to fix this, that 2 times the x. And then this is now going to be negative 1x minus 3. You have to distribute that. Then you can go ahead and drop the 9s, and you get 2x equals negative 1x minus 3. If I add x to both sides, I get 3x. And if I divide by 3, I get negative 1. Okay, second one, like I said before, they already have the same base, so you're able to go ahead and drop it. This one's a little interesting. So if I subtract 3x from both sides, I wind up with 0 equals 0 minus 1. Now my variable cancels out completely, and when this happens, and it does happen sometimes, you're left with either a true or a false statement. Well, last I checked, 0 does not equal to 1, or negative 1. So that is false. If this is false, that means that we have a no solution situation. Basically, what's going to happen is if you type this side into Desmos right here, and you type in this side into Desmos, they will not connect. They will not intersect. There is no solution. And that happens sometimes. So this is our third technique to solving exponential equations. This one is also doing this algebraically. So if you don't have access to Desmos, and if it doesn't fit the base equal base kind of format, then what you can do is maybe possibly change it from logarithm, from exponential to logarithmic form. One way to kind of figure out you're going to have to do something like that is realize that you only have one base. And if you look at this first example here, I only have one base. I have base E. Now, typically on these, you're going to have to do a little bit more work. So the first one, though, is that you have to isolate the base. So what does that mean, isolate the base? See, I've highlighted the E in yellow. I'm going to color everything else. So that's 2 times the base. And this is plus 4 the base. So what you want to do, and I don't care about this 8, it's on the other side. So what you got to do is you got to get rid of the 2, you got to get rid of the 4. You need to pick wisely. Whenever you're solving equations, you always want to try to add and subtract first, then multiply and divide. So we are going to get rid of the plus 4 by subtracting 4. Okay, so I'm getting a little bit closer. This e is almost isolated. I have to get rid of this 2. How do I get rid of the 2? Since it's 2 times e, you want to divide by 2. That's what it looks like, okay? So this is what it looks like when it's isolated. And it looks like it's typical exponential form. You're stuck, you have x in the exponent, and there's really nothing else that you can do other than change it to logarithmic form. So I'm going to write that down. So we are going to change to logarithmic form. If this is base e, you need to use a natural log. The natural log is base e. So it'll be natural log base e of 2 is equal to x. So you've pretty much solved it. All you have to do now is to type in the natural log of 2 on your calculator. And you can do this on your scientific calculator. I just happen to have Desmos up, so I'm going to type in the natural log of 2. And it is approximately 0.693. And I'm going to go ahead and work one underneath it. I think, am I going to do the one underneath it? No, I'm going to do this one. Yep. Okay. So let's highlight the base. This time the base is 5. And I need to get rid of this 3. So I don't have anything added, subtracted. I'm not worried about it. I'm going to go directly into removing this 3. Since it's being multiplied, I am going to divide by 3. Okay, base is isolated. Now what I'm going to do is change it into logarithmic form. I'm going to write log, so a normal log, base 5 of 4 is equal to 2x. Now, you're going to want to get x by itself. So I'm going to divide everything on this side by 2 and the right-hand side. So this is what we call an exact answer right here. And a lot of times on multiple choice tests, they're going to want you to give an exact answer instead of typing in a calculator. So this is an exact answer. If you want an estimated answer, all you have to do is type in log base 5 of 4 divided by 2. But I'm going to tell you right now, that's probably what the answer is going to look like. All right, so I want you to kind of like pause the video and go ahead and work on these next 2 right here and see if you can get the exact answer. Okay, let's see how you did on these. At this point, I think I don't really have to do anything. This 2 is already isolated. So if it's already isolated, I can go straight into log base 2 of 14 equals 4x. So all I have to do now is divide that side by 4. This is going to be my exact answer right here. And if you want, a rounded answer, you can just simply like type that into your calculator. So this is the exact answer. All right, this last one over here, we are going to add 2 to both sides. And then we're going to divide by 3. That way we can get that e isolated. And since it's e, I'm going to use natural log to change it into a logarithm. And that is my exact answer. And if I wanted to change it into something rounded, I can just simply type it into the calculator, the natural log of 3, and I'm good to go. If you're a regular student, you can go ahead and stop the video at this point. But if you're in honors, we are going to we're going to figure out how to solve inequalities. All right, so let's look at exponential inequalities. The rule is going to be using the base equal base format and the first one, and then the second one, we're going to be actually doing something completely brand new. Don't worry, it's not too bad, it's pretty easy. So if you look at the rule here, it states that if your base is greater than the same base, you're going to have to carry that greater than to your exponents. Likewise, if it's less than the same base, your exponents are going to be less than each other in that order. So in this one right here, I see that I've got 2 is greater than 2. Therefore, I can drop the 2's and carry down that greater than symbol, and then simply just solve for x. So x is going to be greater than 1. And I'm going to tell you, if you graph this straight into Desmos, it will shade everything past the 1. And just make sure that you understand that it is not equal to. So pay attention to that sign right there if you use Desmos. Okay, over here on the right-hand side. So what you're going to have to do is you can't really depend on whether it's less than or greater than. So we're going to use a new technique. We're going to take the logarithm of both sides. And you're able to do that. You can choose any logarithm that you want to. So in this case, I have a base 3. So I'm going to choose a logarithm with base 3. What you do to the left, you must do to the right. And you learned a little bit earlier that if you have a log with the base 3 and another base of 3, you're able to cancel that whole logarithm out, and you get x is less than log base 3 of 20. This is the exact answer, but if you wanted to estimate this, type this in your calculator and get a decimal, you can very well do that. And the same thing, if you type it into Desmos exactly like this, it's going to shade less than whatever this value is. All right, that's it for today's lesson, and just let me know if you got any questions. Thanks.